Jai Hind everyone. I, Suvarna Mujumdar, Assistant Professor in Electronics and Communication Department of Ajay Kumar Garg Engineering College, going to discuss about a new topic, that is number system and logic gates. This is the prerequisite for our syllabus, that is microprocessor. So first of all, I am going to discuss about the number system. As all of you are aware that as a human being, we only study first number system, that is decimal number system. In this decimal number system, the base is 10 and we have digits from 0 to 9, and we use this number system to represent our data or our information. But as I told you that microprocessor is a digital circuit and it is a brain, or you can say heart of my computer, or you can say the brain of computer or any electronic automated device. So we can say that microprocessor is a digital circuit which understand only the next system, that is binary number system. Why? Before that, the binary number system is with base 2 and the digits are 0 or we can use 1. Why the computer or any electronic circuit, that is digital circuit, use binary number system? Because here we can use two levels to represent 0 and 1. That is, to represent 0 we use 0 volt, and to represent 1 we will use, either we will go with VCC, that is 5 volt, okay, normally. So we can use only two signal levels, while if we have to use a decimal number system, then we need 10 different levels, and it is very difficult for a system to design with this 10 level. So we need some conversion, or we need to understand how we can go with a normal user will understand decimal, but a computer will understand a binary. So we need another number system which will be in between these two, that is binary and decimal, and that is the hexadecimal number system. Hexadecimal number system. So in microprocessor we have to understand this, because we are using this number system only to deal with microprocessor. Whenever we can say that data is inserted, so we will insert that data in the form of hexadecimal. So in case of hexadecimal number system, the digit will be from 0 to 9 and from A to F. These are the 16 digits and the base will be 16. Okay, so 16 different 0 to 9, that is numbers, and we are using alphabets from A to F. Now we need to understand the relation between all these three number system, that how we will convert the decimal number into a binary number, or a decimal number into an hexadecimal, or vice versa. There is one more number system which is commonly used, is octal. Octal number system. In case of octal number system, the base is 8 and here the digits will be 0 to 7. Okay. So these are the four number systems that we are going to discuss in detail, how we are going to convert these number system, so that we can we can be familiar with this number system, and we will use this number system in writing a program for microprocessor. So just taking an example, first of all, just take an example that 242, this is a number. Now this, if a person like who is not know about microprocessor or any other number system, small kid, he will who know the number system, decimal number, then it will read it as 242. Okay, we always read this number as 242 without any base. But if I mention a base here 8, or I mention a base 16, then the number will be in hexadecimal or in octal. So it varies. Okay, so we have to mention the base if we are not using a decimal number system. In case of binary number system, we will use only 2 digits, that is 0 and 1. So we will have a combination of I will write 1 0 1 1 0. Okay, so this is a binary number representation of any decimal number. Now how can I convert that, what is the equivalent decimal number for this binary? Okay, or you can read this as a unit, tens, 100, 1000, 10,000. You can read it as 10,110 if normal number system we are going, that is decimal. But if I mention it here with a base 2, then you can read it as 1010. Now we need to convert this number. Okay, so for conversion from one number to another, okay, so we are going with that. First of all, I am going to convert from decimal number system to a binary number system. So just take an example of 242. So this 242 is in decimal. So to convert this decimal into a binary number, I think all of you are aware that we have to divide it by 2. Okay, and whatever the quotient, that is 1 2 1, we will write here, and the remainder will be placed outside 0. Then again we will divide it by 2, it will be 6 0, remainder will be 1. Again we will divide it by 2, it will be 30, remainder is 0. 2 15, remainder 0. 2 7, there will be 1 remainder. 2 3, just I will clear it. 1 2 1, remainder is 1. Now again division 0, remainder is 1. Okay, so this remainder from this way, this is LSB, that is least significant bit, and this is most significant bit, MSB. So the equivalent binary number for 242 will be, I will write 1 1 1, 4 times 1, 00 10. Okay, but to remember 242, it is very easy. Instead of remembering this 11110010, okay, but our computer will understand this number, and as a user or as a general man, we can understand this number, means we remember this number. Okay, but we have to convert this number so that computer will understand. If I have to give input as 242, I need some mechanism which will convert this 242 into its equivalent binary number, and it is stored in the register, which is a storage element. Okay, now this is one number system, that is base 10 number system. This is base 2 number system. Now I have discussed about the hexadecimal number system. So how we will convert it into an hexadecimal number? So to convert this into an hexadecimal number, we will make a group of 4 bits. Okay, so we will go with the formation of group here only. So 1 1 1 1 0 0 1 0. Okay, so I will make a group of this 4 bit and I will convert this into its equivalent decimal, or you can say a hexadecimal number. Okay. Similarly, I will make here a group of 4 bits and I can write its hexadecimal. Now, before going to this, we have to convert what will be the equivalency of binary to hexadecimal number. Okay. So, I am going to write here. So, in case of binary, as I told you, that is base 2. Okay. So, I think you all know about the conversion of 242. If I write here 242, 242, what you had pronounced is 200. So, how we can write it? We can write it as 2 into with the base 10 and we have to power 2. Okay. Then 4 into 10, that is to the power 1, plus 2 into 10 raised to power 0. This is the expansion form. You already have studied about this expansion form. Okay. So, if I write this 242, I can write this in expansion form in this way. Similarly, if I have to write this 4 times 1 0 0 1 0, I have to write it in expansion form. So, I have to write here. So, I will write this as here 1 1 1 1 1 0 0 1 0. Okay. So, I will start with this number. I will change the pen color. Okay. From this is base 0 to the 2 to the power 0, then 2 to the power 1, 2, 3, 4, 5, 6 and 7. Okay. So, I will write it as 1 into 2 raised to power 7 plus in expansion form 1 into 2 raised to power 6 plus 1 into 2 raised to power 5 plus 1 into 2 raised to power 4 plus 0 into 2 raised to power 3 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 1 plus 0 into 2 raised to power 0. Okay. So, if you convert this, you will find this. Okay. 2 raised to power 7, that is 128 plus 2 raised to power 6, that is 64, 5, you can convert it. Okay. Similarly, if I have to convert a hexadecimal, or I have to find the relation between a binary number and hexadecimal number, we have to make a group of 4. Okay, and we will use to represent it into a binary number. 242, it's binary. Now, in case of hexadecimal, we will make a bunch of 4 and we will write it as 2. Okay. And here we will make a bunch of this and it will be F. So, how we are going to write this F or 2? So, for that, if you start with 0 0 0, its equivalent hexadecimal, this is binary and this is hexadecimal. It is 0. Okay. In hexadecimal, the next number is 1. I will write, how I will write it as 1? It will be 0 0 0 1 in binary. Okay. 2, it will be 0 0 1 0. 3, 0 0 1 1. We will have this is 1, 2, 4, 8. Just a second, I will make it clear. It is 1, 2, 4, 8. Okay, we use 4 numbers. We can have a maximum 4 ones. So we will have this conversion, and I will have a conversion with representing to decimal also. We will have here this side, we will have decimal equivalent. Okay, so decimal, it is 0, it is 1, 2, it is 3. Okay, now 0, 1, 0, 0. So if you go with expansion form, it will be 1 into 2 raised to power 2, that is 4. So it will be equal to 4. Then if I go with 1, 0, 1, that is 4 plus 1, that is 5. Then it is 6. It is 7. Then 1 triple 0, that is 8. 1 into 2 raised to power 3, that is 8, plus 0 plus 0 plus 0, so it is 8. Now next is 8 plus 1, that is 9. Okay, so till now your hexadecimal number and decimal number same, we will have same combination. Okay, then if I move forward with 1, 0, 1, 0, that is, if I write it, it is 10, but in hexadecimal we will represent it as A. Okay, 1, 0, 1, 1, we represent it as B. 1, 0, sorry, B, then we are having 8 to 10, 11, now we have 12, so 1, 1, 0, 0, 8 plus 4, 12, that is C. 1, 1, 0, 1, 8 plus 4, 12, 1, 13, so it is D. 1, 1, 1, 0, that is equivalent to E, and last all ones, that is F. Okay, so using 4 binary number, we can represent hexadecimal number up to F. Now why we are using this 4 only? Because just I will go with this. Yeah, if you see on left side, this decimal number side, it is 9, and after this if I have to convert this into a decimal number, I have to I will go with expansion form and I will found it as a 10. Okay, then it is 11, 12, 13, 14, and lastly 15. Okay, in case of binary, you should remember that the first digit, single digit, if I consider this as a single digit, it may be 0 or 1, it may be 0 or it may be 1. So I can represent two numbers, 0 and 1. To represent more numbers, more decimal number or more hexadecimal number, I need more bits. So how I can find how many bits I required? Okay, so you can go with this, that if I have to represent 4 numbers, okay, means I have to represent 0, 1, 2, 3, if I have to represent these 4 numbers. So from a single digit, means single bit, I can represent 2 numbers, 0 and 1. To represent 2 numbers, I need 2 raised to power 2, that is I have to represent 2 numbers, so 2 raised to power 2, 4. Okay, so with 2 bits I can represent 4 numbers. So this n, that is 2 raised to power n, it will give me, this n value will give me, if n is 3, I can represent 8. If n is 3, 2 raised to power 3, it is 2 raised to power 3, that is I can represent 8 levels. Okay, so depending, right, in case of hexadecimal we have to use 16, we need 16 levels. So how can I find the 16? What will be the value of this n? So value of this n will be 4. Okay, I will convert this 2 raised to power 4, that is 6, and I equate it 2 raised to power n equal to 2 raised to power 4. Then I will solve it. It is equals to n equals to 4. Okay, so vice versa. If I give you that n is 8, now how many levels you can represent? So you can go with 2 raised to power 8. You can write it like 2 raised to power 8, that is 256 levels you can represent. Okay, you will have 256 levels, or you can say 256 combinations, different combinations. Okay, so using a single bit, single binary digit, we can represent 2 levels. 2 raised to power 1, n is 1, so 2 raised to power 1, so we can represent 2 levels, 0 and 1. So this this is most important thing, because here we have to use this concept while finding out the memory capacity, while finding out the register capacity, while finding out how many bits a processor can process the data. Like you all are aware of that your system is of 32-bit processor, your system is 64-bit processor. Now this 64 and 32, these are the number of bits, 32 bits, but you can have 2 raised to power 32 combinations. Okay, and why we can process each of these combinations, the microprocessor will process each of these combinations. Okay, so you have to find how many combinations or how many levels you can have with 2 digits, 2 bits or 4 bits or 16 bits. Okay, so mostly a microprocessor, if I tell you the capacity, or we can say the processing capacity of any microprocessor, we can write it as 8-bit microprocessor or 32-bit microprocessor. Means at a time that microprocessor can process 32-bit data, but that 32-bit data have a different combination, like this 4-bit. If I say my microprocessor is of 4-bit, if I say the first microprocessor which is evolved is 4-bit microprocessor, so in that case 4-bit means we can have a combination from 00040 to 4 ones. Any of these 16 combination we will give as an input to the microprocessor, and it will process that data, it will store that data. Now to store this information, again we need how many bits, how many storage element. So for each bit we need one storage element. Okay, so we can store 1 bit in one storage element, and that storage element we will discuss later on also, and that is flip-flop. Okay, it is a sequential circuit which is used to store the data. Okay, and that we will see what are these logic gates and what is this digital circuit, sequential and combinational in later case. So you can understand, I think it is clear that decimal number system, hexadecimal number and binary, and we will give our information in this hexadecimal number only to the microprocessor. If I have to give the data in decimal, then I need to convert this, that is I have to make it as BCD and equivalent to BCD number system. Okay, now we will proceed with the octal number, that is one more number system. So I will just erase. Okay, now in case of octal, as I told you, we have to use only 0 to 7 digit. Okay, now again if it is written like 746, no base is given to you, what you can read? You can read it as 746. Okay, but if I write it here at base 8, now it is not 746. We have to convert this into a decimal number, then only we can say what is the equivalent decimal. So how we are going to convert this? Now here in case here base is 8, so we will use 7 into expansion form, we will use with 8 to the power 2, because 0, 1, 2 plus 4 into 8 to the power 1 plus 6 into 8 raised to power 0. Okay, so in general if we consider general case, with this example only I can go with general case, that any number x, y, z is given to you with base r. Any number with base r is given to you, then we have to convert this number into its decimal equivalent. How we are going to do that? We will use this x as a digit, the first digit, into r to the power 2 plus y into r to the power 1 plus z into r to the power 0. Okay, this is all I am considering in whole number side. When we are having a number with decimal like x, y, z dot abc, this is my number, this is decimal. Okay, so this is decimal. Then in that case, after decimal we will having the conversion as a into, for decimal fractional part, for this fractional part, a into r to the power minus 1 plus b into r to the power minus 2 plus c into r to the power minus 3, and so on. We will go if the number is more, the digits are more. Okay, so in this way we will convert the equivalent, whatever the number is base is given to you, you can convert it into its equivalent decimal number. Okay, and if you have to go with vice versa, a number is given in a decimal number and you have to find its equivalent binary or octal, then in that case we have to go with the division procedure. Okay, now just we will have a number 846. I will take this as a number and I will give you at as a base 10. Now I am using base 10, so I have to find its equivalent binary, or I can go with hexadecimal, or I have to find its equivalent octal. Okay, now we have to go with a division procedure. Okay, so just go with octal. If I go with octal, so we will go with 846, so we have to divide it by 8. Okay, remainder is 6. Eight fours are 32. The remainder will be 25. Oh, sorry. Yeah, my mistake. 8 ones are 8. 2, 25. 8 threes are 24. The remainder will be 1. Now again 8. 8 ones are 8. 4 and 5. So remainder will be 5. 8, 0, 1. Okay, so I will represent it as 1516 in octal. Similarly, if I have to find hexadecimal, 846 divided by 16. Okay, sorry. Okay, so here we will divide it by 16, and if I have to go with binary, then I will divide it by 2 and I will find the remainder. Okay, so in this way we will have a conversion from decimal to binary or hexadecimal and octal number system. In next lecture I am going to cover about the logic gates. Thank you.